lots of words. Okay, so besides this possibly Canadian way of spelling traveling, okay, we got the same situation that we've always had. We have a velocity, we have a graph, and we have a table. Look at your paper. Do you have this table?
No.
No. So why don't you take a minute and go ahead and copy that table down. Okay, so some of these questions are going to be things that we've already done. Some of it's going to be the new stuff. So you don't really know what's which. You just kind of have to read a question and think what makes sense here. So during what intervals of time is the acceleration of the car positive? So what do you think? Do we need to do a Riemann sum to answer this question? No. This is something we've already done. How is acceleration related to velocity? It's a derivative. Okay, so we're really looking for where's v prime positive, or more specifically, where's the velocity increasing? And so we're going to write an interval for our answer here. So we got 0 to, looks like this stops at about 35, stops increasing. And then there's another section of increasing. So we put a union sign. And what would the second interval be? 45 to 50. Good. Our justification here has to be something about because velocity something. Because we're given information about velocity, our justification has to be in terms of velocity. So probably the easiest way of saying this is because velocity is increasing. All right, so for part B, average acceleration. Now, yesterday I talked about average value, and last semester we talked about average rate of change. So here's how you know the difference, and this is a conversation we're going to have a lot this semester. Are you trying to average this thing itself, okay, or this thing, or are you trying to average that thing's rate of change? The second one. So let me repeat that again, just make sure everybody has got this. If we're trying to average this thing itself, that's the new concept, average value. If we're trying to find average rate of change, which we are, right? Acceleration is the rate of change of velocity. Then that's just an AROC problem, average rate of change problem, which we did all last semester. So how do you do average rate of change? Just give me a one-word answer. Slope. We do slope. All right, so they tell us the interval to choose. So we're going to do velocity at 50 minus velocity at 0, so change in velocity, over change in time. This is just the slope formula. It's just the same as y2 minus y1 over x2 minus x1. Okay, this is where we use the table. So v of 50, we look it up, it's 72. V of 0 is 0. And although you don't have to simplify here on an open-ended, let's go ahead and do it just for practice. And you can use your calculator here. It's okay to write it as a fraction. I'm going to go ahead and write it as a decimal, just because, not for any special reason. It doesn't really matter. In fact, you can leave your answer like this on the AP test. We would want to go ahead and write the units. Now, they were nice and gave us the units. But let's say they didn't. How do we know the units are feet per second squared? Because it's acceleration, and acceleration is always like distance per time squared. Think about what are the numbers that we plugged in here. 72. 72 was in feet per second. So feet per second. I can write it as feet over seconds. Divided by 50. So divided by seconds. Now, if you look at this and you're like, is that feet per second squared, or do the seconds cancel? You could have left your units just like this, and that's totally acceptable. That would be better than mistakenly canceling the seconds out. Okay, but that is feet per second squared. Really, the word acceleration is what I would go with here. Okay, so then we get to part C, and it says find one approximation. What is that kind of like telling us might happen? There might be more than one answer. So we just have to find one. Find one approximation, so not even exact, for the acceleration. So again, we're going to find acceleration. This time, though, it doesn't want it over an interval. It wants it at a specific number. So it would be great if we had an equation up here somewhere that we could derive and then plug in 40. But we don't. This is why it says approximation. So although it's asking us to find instantaneous rate of change, they're asking for an approximation. So this is really just another average rate of change. What you have to decide, though, is what numbers am I going to choose? Because I get that at 40, the velocity is 75, but I need to do a change of some sort. Basically, I need to do what we did in part B. So what times are really close to 40? 45 and 35. And this is where this is why this says one approximation. This is probably what most of you would pick, and this is what I'm going to pick. V of 45 minus V of 35 over 45 minus 35. It would have been okay here if you had done V of 45 minus V of 40 over 45 minus 40, or done 40 minus 35. That would have been okay. That's why that language is there. And just to make sure everybody really understands this, they're asking us what is the slope at 40, and what we're going to do is find the slope around 40 and say that that's pretty close. It's just approximation. Okay, so go ahead and try to finish this one out and go ahead and get an answer here and write your units and all that good stuff. Mm-hmm.
Once if we would have used like a factor form, or actually just like divided it out, like for like negative 2.1.
If you wrote 60 minus 81 over 10 or anything equivalent, you're good. You don't have to write the negative 2.1. In fact, if you write correctly 60 minus 81 over 10, but then somehow make a mistake here, you just lost the point you just earned. So, closer to the AP test, I'm going to encourage you not to simplify. For now, we are going to go ahead and do that because we don't just have open-ended questions. We still are going to have some multiple choice questions we have to simplify on. And again, the units are feet per second squared. Okay, so that was all old stuff. That was all stuff you guys saw in your after parties last semester, a little bit of this stuff on your exam and all that. A little rusty, but it'll come back. Okay, so part D, I see the integral symbol. Remember, this symbol stands for integration, integral. We're going to talk more about that in chapter 4, but for right now, we know that we do a Riemann sum. That's all we know about this symbol is right now we have Riemann sums. And so anytime you're like thinking, do I need to do a Riemann sum here? It's going to tell you. It's going to say, do a Riemann sum. It's going to tell you which type of Riemann sum. And it's going to say something about the subintervals. All right. In this case, 5 subintervals of equal length. On your homework, you're going to see a couple of them where it's not equal length. And I'm going to let you try to work that out on your own, and I'll help you, and we'll go over it tomorrow. But this one is 5 subintervals of equal length. So looking up at the table, what is each interval going to be? 10. Okay, and I'm going to go ahead and do this. It's going to help me with the next step. So I can see here that there are 10 10 seconds in each subinterval. That should really go down to like where the 10 is. And there are 5 total. Notice that where 10 seconds finishes the first subinterval and it starts the second subinterval. It's not like the first one ends at 10 and the next one begins at 15. That's a common mistake. Okay, I'm going to go ahead and write out here, A equal 10. All right, so without drawing the rectangle, how are we going to do this? Well, if I just for a second, don't do this on your paper, obviously, but I'm going to scratch that out. And I'm just going to look at this information. Okay, here's my 10 seconds. Out of these 3 numbers, which one would you pick for a left Riemann sum?
0.
0. Okay, this table is vertical, so it's kind of different, but you could think about what it would look like if it was horizontal table. 0 would be the left, 20 would be the right, and 12 would be the midpoint. Okay, and that's what they're asking us to do. So I'm going to erase that. So my first rectangle is going to be 12 times the change in time, which is 10. That's how you do it without looking at the graph. Okay, looking at the graph, you would say, okay, here's 10 seconds. Out of these 3 points, 1, 2, 3, I'm going to pick the middle one, and you would analyze that picture and try to find the area of that rectangle. Ultimately, I want you guys to be able to do this without drawing the rectangles. It's time consuming and you're not always given a graph, and that can take up more time than it's really helping you. Okay, so then what would be the next one? This 10 to 20 second interval. Which velocity are we going to choose? 30. Right? Because 10 seconds to 20 seconds, this is what we're choosing right here. And so you have these 3 numbers to choose from for your velocity. We're going to choose 30. And what are we going to multiply 30 by? 10. Okay, go ahead and try to finish this one out on your own. And if you need to, draw it. There's really no shame in this. We're still learning it, so. If you're already done with D, go ahead and try E. Because each subinterval is 10 seconds. Yeah. And again, although you don't have to simplify, go ahead and do that just to make sure that we're getting the same answer.
Is it just feet or feet squared?
Okay, I kind of gave that away. I didn't mean to write this, so I'm going to play dumb for a second. It's not wrong, but I'm going to erase it. I'm going to play dumb. Okay, are we getting 2,530? Okay. So then we got to figure out our units and explain the meaning. Really, explaining the meaning is a lot easier if you know your units. So think about like what we're multiplying. We were multiplying 12 feet per second times 10 seconds. So earlier we were doing feet per second divided by seconds. That was feet per second squared. What's happening in this case? Because we're multiplying. They cancel and you're left with just feet. And this is really nice because this helps us know what we found. Because if you have the correct units, you can say, okay, feet, I know feet, that's distance. That's a distance. It's not a velocity or an acceleration or a time. So you go from that word. Distance, what? What distance? The total distance traveled. If you just wrote distance traveled, that would be okay. So total distance traveled, and then there's one other thing I need to put here. And that is, it's not like this is just for all time. This is only on this specific interval. So I need to write the interval. It's on the interval 0 to 50 seconds. I have mentioned this before, but I'm going to go ahead and mention it again. And as we go, you'll hear this a few other times. But there's an acronym that you may find useful when making sure that you interpret the meaning. Okay, the C stands for context. You have to put something about the problem, right? In this case, it was the distance traveled. It wasn't temperature or anything, gallons, anything like that. It was distance traveled. What do you think the U stands for?
Units.
Units. You got to have correct units if you're going to interpret a meaning.
Total.
T, not total.
Traveled.
Keep going. Time. You have to relate it back to the time that they said. Okay, because this car didn't travel this distance forever. It was just during this specific time. So context, units, time. Some people like this. Some people don't really need that. It's going to be something I mention a lot more getting closer to the AP test. Okay. E. Last question. Based on the values on the table, what's the fewest number of times that the acceleration could equal 0 on this interval? So it says to use the table, and we could, but it's actually a little bit easier to use the graph. So I'm going to erase this off a little bit.
This one we're talking about when slope is 0.
Yeah, because we even found in part A that acceleration was this graph slope. So where is this graph slope equal to 0? Up here. 35 and 45, which we don't have to list. So twice, that's our answer. The fewest number of times that's going to happen is twice. We have to write a justification, and our justification has to be because velocity something. Velocity is what they gave us. That's what we have to use to explain. So velocity is doing what 2 times?
Velocity is changing direction.
Let's be a little bit more specific and change directions. Changes from increasing to decreasing, and then decreasing to increasing. This is one way of saying it, and this is what I think most people would come up with. It's a little wordy, but it means like what you probably were looking for. Anybody think they could think of something else? What are there 2 of on that graph? Relative extrema. Relative extrema. So you could have also said velocity has 2 relative extrema. This is probably, though, really what most people would put. Okay? I'm going to put this in the video. Okay, so here is your homework. We already checked page 6. So if you have not already done pages 7, 8, and 9, I am going to check this tomorrow, which is Friday. Okay, so pages 7, 8, and 9, I'm checking that Friday. That's the standard of the quiz. All right, pages 10 and 12, that's like what we just did, and I'm going to check that Monday. So if you want to get this all done tonight and not have homework, that would be great. But there you go.
So I guess stuff on 10 and 12 is not done.
Right. I mean, there's some overlap, but there's no AP style problems.